In the brutal calculus of modern air power, where every bolt, every composite panel, and every line of code can dictate the outcome of a battle, the most unforgiving variable is not thrust or payload, but fuel. It is the lifeblood of aerial warfare, and its limitations impose a tyranny of distance that has historically tethered even the most advanced air forces to their home bases. An aircraft without fuel is merely a sophisticated glider, its billion-dollar avionics and lethal munitions rendered inert. It is in this context that the aerial tanker, often relegated to the unglamorous role of a support asset, reveals its true nature. It is not a follower of the fleet, but a kingmaker, an aggressive enabler of strategy that anoints fighters and bombers with the divine right of reach. For decades, the People's Liberation Army Air Force, PLAAF, labored under this tyranny, possessing a formidable but geographically constrained air arm. Its tanker capability was, to be generous, negligible, consisting of a handful of converted Xi'an H-6 bombers, themselves based on the 1950s-era Soviet Tu-16, and a trio of second-hand Ilyushin Il-78M jets acquired from Ukraine. This small, aging fleet represented a critical strategic gap, a tether that kept its ambitions firmly leashed within the first island chain. Subscribe to stay updated on new analyses and breakdowns of emerging technologies and military hardware. The arrival of the Xi'an YY-20, an aerial refueling tanker based on the formidable Y-20 strategic transport, is therefore not merely an incremental upgrade. It is the severing of that tether. It is the physical manifestation of a doctrinal shift, a clear signal of China's intent to transform from a regional power into one with the capacity for sustained, long-range power projection. The central sensation surrounding its debut, a claim that this new sky tanker effectively doubles the combat range of the J-20 stealth fighter, is more than just a headline. It is a thesis statement for a new era in Indo-Pacific military geography, one where the vastness of the ocean is no longer a sanctuary for China's potential adversaries. The foundation of this strategic sea change is an aircraft of immense proportions and surprisingly modern pedigree, the Xi'an Y-20 Strategic Airlifter. Officially codenamed Kunpeng after a mythical Chinese bird capable of flying for thousands of miles, it is more affectionately known within the Chinese aviation industry by its nickname, Pang Niu, or Chubby Girl. The moniker is not one of derision, but of endearment, born from its conspicuously wide and voluminous fuselage, a design feature that makes it ideal for swallowing oversized military cargo like main battle tanks, and also, as it turns out, for carrying the colossal internal fuel loads required of a modern tanker. The Y-20 project, which officially began in July 2007, represents a significant leap for China's aerospace industry, which has long been characterized by a reliance on reverse engineering Soviet designs. While its general configuration, a high-wing, T-tailed layout with 4 pylon-mounted turbofans, bears a functional resemblance to the American C-17 Globemaster III and the Russian Il-76, the Y-20 is an indigenous design brought from concept to reality with astonishing speed. The first prototype took flight on January 26, 2013, and the aircraft officially entered service with the PLAAF in July 2016, a development cycle far shorter than many of its predecessors. This accelerated timeline was not the result of engineering shortcuts, but of a fundamental shift in design philosophy. The Y-20 was the first cargo aircraft in China to make extensive use of 3D printing for components, and more significantly, was only the third aircraft in the world, after the Airbus A380 and Boeing 787, to be designed using model-based definition, MBD. This digital-first approach, where a 3D model serves as the single source of truth for all engineering and manufacturing data, reportedly reduced design work by 40% and slashed the manufacturing cycle by 30%. The program's chief designer was so committed to this new methodology that teams refusing to implement MBD were barred from participation, forcing a cultural shift that prized digital efficiency over legacy processes. The airframe itself is a robust military design, with a wingspan of 50 meters and a length of 47 meters, capable of a maximum takeoff weight of 220,000 kilolars and lifting a 66-ton payload, such as a single Type 99A main battle tank. Its heavy-duty landing gear, with 3 rows of wheels per side, and its high wing configuration are optimized for stability and operations from the sort of short, unpaved, or damaged airfields one might expect in a contested environment. Yet, for all its advanced design principles, the initial production models of the Chubby Girl carried a notable asterisk. Its 4 power plants were imported Russian Soloviev D30KP2 turbofans, a capable but fundamentally 1960s vintage Soviet design. It was a pragmatic compromise to get the aircraft flying, but also a slightly awkward reminder of a lingering technological dependency for a program meant to be a showpiece of Chinese self-reliance. The transformation from a heavy hauler into a strategic gas station, a process that saw the Y-20 airlifter evolve into the YY-20 tanker, is a study in pragmatic engineering. Officially designated YY-20, but also referred to in various analyses as the Y-20U or YY-20, the aircraft's modifications are centered on the installation of a comprehensive aerial refueling system. Satellite imagery first hinted at the tanker variant's existence in 2018, revealing an airframe fitted with refueling pods, and by 2022, the type was officially in service and participating in combat readiness training. The system chosen by the Xi'an Aircraft Corporation is a 3-point probe and drogue configuration, featuring 2 refueling pods mounted under the outer wings and a third, larger unit on the left side of the rear fuselage. This layout is broadly similar to that of the Russian Il-78 Midas, an aircraft with which the PLAAF already had operational experience, albeit with a very small fleet. The choice of the probe and drogue method over the flying boom system, favored by the U.S. Air Force, is a decision rooted in both practicality and doctrine. The probe and drogue system, where a receiver aircraft's probe connects to a basket-like drogue trailing from a flexible hose, is mechanically simpler to integrate onto an existing airframe and allows a single tanker to refuel multiple aircraft simultaneously, a significant advantage when topping off a flight of fighters. Crucially, the entirety of the PLAAF's current combat fleet, from the J-10 and J-16 fighters to the J-20 stealth fighter and the H-6N bomber, is equipped with refueling probes, making this system the only viable immediate option. This approach minimized development risk and ensured the YY-20 could be rapidly integrated into the existing force structure. The YY-20 is reported to carry approximately 90 tons of transferable fuel, a colossal increase over the roughly 30 tons offered by the legacy H-6U tankers, and on par with the capacity of the Il-78M. While a definitive public figure for its fuel transfer rate remains undisclosed, it is expected to be similar to that of the Il-78, which can deliver between 900 and 2,200 liters per minute, depending on the refueling point used. A key question that remains is whether the YY-20 is a dedicated tanker or retains a dual-use cargo capability. Early analysis suggests that, like the Il-78, the initial YY-20 variants are convertible, preserving the rear cargo ramp to allow the aircraft to serve as a transport when not fitted with internal fuel tanks. For an Air Force still in the process of building up its overall strategic airlift fleet, this flexibility is a valuable asset, even if it comes at the cost of optimized performance as a dedicated tanker. If the Y-20's airframe represents a mastery of modern design processes, its engine evolution represents the conquest of a far more difficult and strategically vital frontier. The single most critical upgrade to the entire Y-20 platform, and the key that unlocks its full potential, is the replacement of the venerable but performance-limiting Russian D-30KP2 engines with the indigenous Shenyang WS-20 high-bypass turbofan. This transition marks the moment the aircraft truly comes of age, shedding its last major foreign dependency and becoming a wholly Chinese strategic asset. The development of a reliable, high-performance, high-bypass turbofan engine is widely considered one of the pinnacles of aerospace engineering, a club with very few members. China's long struggle in this domain has been a well-documented bottleneck, forcing its most advanced fighters and transport aircraft to rely on Russian or reverse-engineered power plants. The WS-20, derived from the core of the successful WS-10 engine used in fighters like the J-16, breaks this cycle. The technical benefits are profound. Each WS-20 produces approximately 140 kN, 31,000 lbf of thrust, a significant increase over the D-30's 118 kN, while also being lighter and substantially more fuel efficient. This additional power and efficiency were always part of the Y-20's design specifications. Indeed, the aircraft could not achieve its maximum 66-ton cargo capacity without them. For both the transport and tanker variants, the WS-20 translates directly into improved performance across the board. Longer range, greater payload capacity from a given runway, and better short takeoff and landing capabilities, particularly from the high-altitude airfields on the Tibetan Plateau that are of immense strategic importance to China. In-flight testing of the WS-20 on the Y-20 platform was observed as early as 2020, and by 2023, the Y-20B variant, distinguished by its new engines, had entered operational service. More than just a technical upgrade, the successful fielding of the WS-20 is a moment of strategic liberation. It removes a critical vulnerability to foreign sanctions or supply chain disruptions and ensures that China can produce the Y-20 and its growing family of variants, including the YY-20 tanker and a future airborne early warning and control AEW&C version, at a rate limited only by its own industrial capacity. The WS-20 is not just an engine for one aircraft. It is a foundational technology that will power China's large aircraft ambitions for decades to come. To accurately gauge the YY-20's significance, it must be measured against its international peers in the demanding field of aerial refueling. This is a crowded sky, dominated by three other major players: the Russian Ilyushin Il-78M Midas, the European Airbus A330 MRTT, and the American Boeing KC-46A Pegasus. A clinical comparison reveals that each aircraft is a reflection of the unique doctrine, industrial base, and strategic priorities of its operator. The YY-20, with a maximum takeoff weight, MTOW, of around 220 tons and a transferable fuel load of approximately 90 tons, is conceptually a direct successor to the Russian Il-78M. The Il-78, with a slightly lower MTOW of 210 tons, is a dedicated tanker that can offload a larger fuel volume of up to 105.7 tons by eliminating all cargo handling equipment. Both aircraft are based on rugged, purpose-built military transports and utilize a three-point probe and drogue system. This militarized transport philosophy prioritizes robustness, simplicity, and the ability to operate from less than perfect airfields. It is an approach born of a need to field a large, reliable tanker fleet quickly to address a pressing strategic deficit. In stark contrast stand the Western competitors, which follow a commercial derivative philosophy. The Airbus A330 MRTT is the heavyweight of the group based on the successful A330 airliner. With an MTOW of 233 tons, it boasts the largest fuel capacity, able to carry 101 tons of fuel without requiring additional tanks in the cargo bay, thus preserving its immense flexibility for carrying passengers, cargo, or medical evacuation litters. It offers a combination of a flying boom and underwing probe and drogue pods, making it compatible with nearly any receiver aircraft in the world. It represents the high-end, highly flexible, but also most expensive solution. The American KC-46A Pegasus, derived from the Boeing 767 airliner, is a more compact platform with an MTOW of 188 tons and a fuel capacity of 96 tons. Like the A330, it features both a boom and drogue systems. However, its design philosophy emphasizes survivability and network integration. Boeing markets it as a combat aircraft equipped with defensive countermeasures, cockpit armor, and advanced data links to function as a node in a networked battlespace. The YY-20 fits neatly between these paradigms. It lacks the multi-role elegance and higher fuel capacity of the A330 MRTT and the advanced networking and defensive suites of the KC-46. However, its military-first design likely gives it an edge in austere environments, and its simpler systems are conducive to the mass production needed to rapidly expand the PLAAF's tanker fleet from a few dozen to a projected 75 or more aircraft by the early 2030s. The YY-20 is a solution born of strategic urgency, a good enough platform that can be fielded in numbers sufficient to fundamentally change the military balance, rather than a more exquisite system that might take longer to mature. The technical specifications of the YY-20, while impressive, are merely the preface to the story. The true narrative lies in its strategic ripple effect, which is already redrawing the operational map of the Indo-Pacific. The sensational claim that the tanker doubles the range of the Chengdu J-20 Mighty Dragon stealth fighter requires careful deconstruction. In military aviation, the critical metric is not ferry range, but combat radius, the maximum distance an aircraft can fly to a target, engage in combat, and return to base without refueling. The J-20 already possesses a formidable combat radius, estimated at between 2,000 and 2,200 kilometers, which significantly outranges its American counterpart, the F-22 Raptor, with its radius of roughly 850 to 1,220 kilometers. With a single aerial refueling from a YY-20, the J-20's combat radius is credibly estimated to extend beyond 3,000 kilometers, with its maximum range pushing past 10,000 kilometers. This single capability pushes the J-20's engagement envelope from the coast of China deep into the Philippine Sea, allowing it to threaten assets well beyond the second island chain. The impact on the PLAAF's bomber fleet is even more dramatic. The H-6N, the most advanced variant of the venerable bomber, has an unrefueled combat radius of over 3,500 kilometers. With aerial refueling, its operational radius expands to a staggering 12,000 kilometers. This transforms the H-6N from a regional threat into a strategic platform capable of launching its long-range cruise and ballistic missiles from standoff positions far out in the Pacific, holding key U.S. bases in places like Guam at risk. The primary strategic effect of the YY-20 is not merely to make individual aircraft fly farther, but to enable the formation of integrated, long-range strike packages that create a layered and exponentially more complex threat. Without tankers, a J-20 escort could only accompany a bomber for a fraction of its mission. With the YY-20, a single cohesive strike package can be formed and sustained. Tankers can top off H-6N bombers en route to their missile launch points, while other tankers refuel their J-20 escorts, allowing the fighters to provide protection throughout the mission and engage any interceptors thousands of kilometers from the Chinese mainland. This capability is being actively honed. YY-20s have been observed supporting long-range PLAAF flights into Taiwan's Air Defense Identification Zone, demonstrating the ability to sustain operations over water. In a significant display of growing expeditionary capability, a YY-20 refueled 7 J-10 fighters en route to a defense show in Saudi Arabia, and others have participated in complex joint exercises with the Egyptian Air Force, refueling their MiG-29 fighters midair. This creates a synergistic problem for any adversary, who must now contend not with a lone bomber, but with a fully escorted, networked, and long-legged strike force, turning what were once considered safe rear areas into potential front lines. The YY-20 is, by any objective measure, an unqualified success. It is a force multiplier that has decisively closed a critical capability gap for the PLAAF, providing the logistical legs required to fulfill China's strategic ambitions. It stands as a powerful testament to the remarkable maturation of the country's aerospace industry, which can now design, produce, and field complex, large-scale military aircraft at a rapid pace. However, this hardware revolution, impressive as it is not the complete story. A note of analytical caution is warranted, for while the PLAAF has acquired the tools of a global air power, the artisans to wield them may still be in training. The most advanced aerial tanker is only as effective as the pilot in the receiver aircraft and the command structure orchestrating the mission. The PLAAF itself has acknowledged deep-seated challenges in its training culture, with official reports citing the need to fight fraud, sham, and laziness, and to move away from rigid, heavily scripted exercises that stifle pilot autonomy and fail to replicate the chaos of actual combat. Unlike their Western counterparts, who have decades of continuous combat operations to draw upon, PLAAF pilots and their commanders have a complete lack of modern combat experience. An experience gap that may be the force's most significant and, in the short term, perhaps unfixable vulnerability. Having a state-of-the-art gas station in the sky is one thing. Having a cadre of pilots with the skill, initiative, and institutional freedom to use it effectively in a dynamic, high-end fight against an experienced adversary is another entirely. The PLAAF now faces a potential brittle force dilemma. It possesses advanced technology that on paper makes it appear competitor, but the underlying human and institutional software may not yet be robust enough to withstand the immense pressures of real-world conflict. The YY-20 has unquestionably redrawn the strategic map and provided the PLAAF with the option of long-range power projection. The coming years will reveal whether it has also forged the doctrine and the warfighters capable of turning that option into a decisive reality.